Hey, it's Mr. Lineski with Unit 4, Section 4, CPCTC. What the heck does that mean? Let's take a look. CPCTC stands for Corresponding Parts of Congruent Triangles are Congruent. I want to start off by specifying that CPCTC is not used to prove triangles are congruent. So it's something that we use after we've established that the triangles are congruent. And so what exactly does it do? Once we prove that two triangles are congruent, we essentially unlock all of the missing pieces. So when I say we prove two triangles congruent, that is referring to one of these things. Those are our ways of proving triangles congruent. And so once I prove those two triangles are congruent, I now sort of have unlocked all of that. And so, like for example here, with side angle side, I have two sides that are marked congruent and only one pair of angles. There's two other pairs of angles and one other side pair that didn't get marked congruent. So once I prove the triangle is congruent, I can now say that all those other things are also congruent. So let's take a look at how this thing's actually used in action. So we're going to take a look at our proof here. Given that QT is congruent to RS, and QR is congruent to TS, we're trying to prove now that an angle is congruent to another angle. So one thing I want to point out here is that a hint on how to know to use CPCTC is that if you prove a statement is something besides proving the triangles are congruent, you'll use CPCTC. So for example, on section 4.3 here, our prove statement was to prove the two triangles were congruent. Now I'm just proving that two angles are congruent. So that's kind of a heads up as to, hey, I need to use CPCTC. And so as always, we're going to start with our givens. Don't forget to mark your figure, QT, RS. Can't do anything else with that. Hey, that's a star though. QR congruent to TS. That's also given. That's also a star. Don't forget to mark. And so now the idea is, well, where do I get my third congruency from? I get my third congruency again from that reflexive property. I can say RT is congruent to RT. There's my third congruency. That was reflexive. And so remember, when you get 3 stars, you can now establish that the two triangles are congruent. And so we're still doing that. Nothing is changing. So I'm still now going to say that triangle TQR is congruent to triangle RST. And the reason for that was side, side, side. So now I know that the triangles are congruent. Now I can mark all of these other things congruent. But I don't need to do all of it. I just want to do the ones that I'm interested in. So the one that I'm interested in here is proving that angle TQR is congruent to angle, whoops, not triangle, sorry, is to prove that angle RST are congruent. And so that's this angle and this angle. And so why am I allowed to say that those angles are all of a sudden congruent? Because the corresponding parts, these angles are corresponding, the corresponding parts of congruent triangles are also congruent. That's what CPCTC stands for and is used for. Let's take a look at another example here. So if we are given that I is the midpoint of GK and JH, and we're trying to prove that GH is congruent to JK. So notice, I'm not really given much here. All I know is that this point right here is the midpoint of JH and GK. So let's again kind of work one thing at a time here. So state our given. I is midpoint of GK and JH. And so that is given. And so now the idea again is, what can I pull from the midpoint? From this being the midpoint, I can state that GI is congruent to IK. And that is the definition of midpoint. Well, it's not just the midpoint of GK, it's also the midpoint of JH. So that means it's also cutting JH in half. And so I can say that JI is congruent to IH. And I can say that because of definition of midpoint again. It's totally fine to use the same reason twice in a proof. Not a problem. So we need to also keep track. We have stars going on here, two congruent statements. And so we, again, are looking for how can I prove these two triangles are congruent. Hopefully you're noticing that we have vertical angles here. So that's going to be our last star. So I can say that angle JIK is congruent to angle GIH. And the reason for that is vertical angle congruence theorem. So that's my third star. So now how did I prove these two triangles congruent? So don't forget the rule that if you're looking at how did I prove the triangles congruent, cover up one of the triangles. What do you have marked? Side, angle, side. And so that's how we proved those two triangles are congruent. Make sure you're paying attention to order. So I'm going to go 1 tick mark to angle to 2 tick mark. So angle KIJ is congruent to triangle, sorry I said angle, triangle is congruent to triangle, so 1 is GIH. Always make sure that the parts match up. Imagine matching up the parts. And so the reason for that was side angle side congruency. And so now that I proved the triangles are congruent, anything that was not marked, so basically anything down here, this side, these two angles, this side, these two angles, I can now establish that those are congruent. But I just want to know that GH is congruent to KJ, and I'm going to use CPCTC. As a reminder, corresponding parts of congruent triangles being congruent do not prove triangles are congruent. So just make sure you remember that fact. You have to use one of those 5 things that we talked about here. Alright, that is all for section 4 of Unit 4. Thank you for watching. I know it, now you know it.